USS Franklin was burning only 50 miles from the Japanese home islands. For 10 hours, fires moved through aircraft, bombs, rockets, and aviation fuel, yet the carrier would eventually escape under her own power. The question is not simply how her crew fought the flames. It is why those flames failed to destroy the machinery beneath them. On March 19, 1945, Franklin was launching strikes against Japan. Her flight deck held 31 aircraft prepared for operations. Another 22 aircraft waited inside the hangar. Many carried fuel, bombs, or rockets. That concentration transformed one successful attack into a chain reaction. Shortly after 7 in the morning, the radar picture appeared clear. The immediate threat seemed to have passed. Some men left their battle stations to eat. Aircraft were being warmed, armed, and moved for the next launch. Then a Japanese dive bomber emerged from low cloud. It crossed the carrier before the ship could mount an effective defense. 2 bombs struck within seconds. The first penetrated near the flight deck centerline. It detonated inside the forward hangar and hurled the forward elevator upward. The second struck among aircraft crowded farther aft. Its explosion disabled the after elevator and opened another path for fire. The initial bombs caused severe damage, but they were only the ignition source. Burning fuel spread between armed aircraft. Bombs began cooking inside the heat. Rockets fired unpredictably across the decks and into the air. Ready ammunition followed. Investigators later counted 126 secondary explosions. Within minutes, Franklin lost much of her firefighting capacity. Smoke and heat forced men from critical engineering spaces. Electrical power failed. Communications broke down. The carrier stopped and began drifting near the enemy coast. From surrounding ships, Franklin appeared beyond recovery. Her flight deck had become a continuous field of smoke and flame. Explosions repeatedly scattered the men trying to contain it. Water poured into damaged compartments and increased the starboard list. The instinctive conclusion was brutally simple. A carrier carrying fuel and ammunition could not burn like this and remain alive. But Franklin possessed an advantage hidden beneath the visible destruction. The principal strength structure had not failed. Her underwater hull remained substantially intact. No torpedo had torn open the compartments below the waterline. Most importantly, the armored section beneath the hangar absorbed and contained damage from above. That protection did not stop the fires. It helped prevent them from immediately destroying the machinery below. The ship was dead in the water, but she was not structurally doomed. That distinction created a narrow opportunity. It still required people willing to use it. Hundreds transferred to assisting ships as the situation deteriorated, yet 103 officers and 603 enlisted men remained aboard. Some were trapped by circumstances. Others stayed because abandoning the carrier would surrender its last surviving systems. Their first objective was not restoring propulsion. It was keeping Franklin stable long enough for propulsion to matter. Fire parties worked without a dependable fire main. Men carried extinguishers into smoke-filled passages. Others cooled ammunition before it could join the explosions. Damage control teams counterflooded carefully while firefighting water accumulated above them. Each action solved one danger while creating another. More water reduced fire. More water also threatened stability. By late morning, the fires still dominated the upper decks. Franklin could not steer or move. A tow was being prepared while Japanese aircraft remained a continuing threat. The crew had preserved the hull. Now they had to discover whether anything below the wrecked hangar could still be restarted. Below the burning hangar, nearly 300 men found every normal escape route blocked. Smoke filled their compartment while explosions shook the decks above them. One engineering officer promised he would find another way out. Lieutenant Donald Gary knew Franklin's internal spaces unusually well. He had served as an enlisted machinist before receiving his commission. Now that knowledge mattered more than rank. Gary took an oxygen-breathing apparatus and entered the darkened passageways alone. Its air supply was limited. The route ahead was twisted by heat, wreckage, and damaged ventilation trunks. He moved through roughly 600 feet of obstructed ducting and uptakes. Eventually, he found a route leading toward breathable air. Gary could have remained there. Instead, he obtained another breathing apparatus and returned to the trapped compartment. He made the journey 3 times. On each return, he led a larger group through smoke and debris. The escape route saved between 250 and 300 people. That rescue revealed something important about Franklin's survival. The ship did not depend upon one functioning command center. Small groups were solving separate emergencies without reliable communication. On the exposed decks, Chaplain Joseph O'Callahan became another visible center of authority. A white cross marked his helmet. He assisted injured sailors, carried supplies, and helped organize men around the fires. He entered threatened gun positions where ammunition was becoming dangerously hot. Shells had to be cooled or thrown overboard before they exploded. Nearby, medical personnel created treatment stations wherever space remained usable. The normal sick bay could no longer support the scale of the emergency. The cruiser Santa Fe moved alongside Franklin, despite flames and continuing explosions. That position exposed Santa Fe to debris and possible detonation from the carrier. It also allowed rescuers to transfer injured men and remove survivors from danger. Fire hoses and assistants crossed in the opposite direction. The operation reduced the number aboard Franklin. It did not mean the carrier had been abandoned. Captain Leslie Gares remained responsible for a ship still drifting near Japan. Destroyers screened the carrier while friendly fighters guarded the air above. The heavy cruiser Pittsburgh prepared to tow the crippled vessel away. Before that tow could save Franklin, however, the crew had to control her list. Firefighting water had accumulated faster than damaged drainage systems could remove it. The weight pulled the carrier progressively to starboard. A ship may survive fire and still capsize because of the water used against it. Damage control teams shifted weight and managed flooding below. Their work slowly reduced the immediate stability crisis. By early afternoon, Pittsburgh had Franklin under tow. The carrier began moving away from Japan at only a few knots. That was the first clear payoff. Franklin no longer had to remain inside the enemy's coastal approaches, but the tow solved only the problem of distance. It could not make the carrier independent. A towing line could part. Another air attack could force the cruisers and destroyers to maneuver. Franklin still lacked dependable steering, electrical service, and propulsion. Gary, therefore, went below again. The first and second fire rooms could not be restored. The third offered a smaller possibility. Working amid heat, smoke, and damaged equipment, Gary directed men attempting to raise steam in one boiler. This was not yet enough to drive the carrier. It was enough to begin rebuilding a functioning system. Steam could support pumps. Pumps could remove water. Auxiliary power could restore communication and control. Each recovered service increased the chance of recovering another. The carrier's survival was becoming a chain reaction in reverse. Yet the fires had not finished testing that chain. Aviation fuel continued, burning near the stern. Smoldering spaces remained inaccessible. And while Pittsburgh pulled Franklin through the water, another Japanese aircraft found the damaged formation. The expected attack did not arrive while Franklin remained helpless that afternoon. It came after the crew had restored movement and released the tow. Survival had made the carrier a target again. Through the night of March 19th, Pittsburgh continued pulling Franklin away from Japan. Fire parties still searched compartments where heat concealed smoldering material. Gasoline fires near the stern repeatedly returned. Some spaces would continue burning until March 22nd. Below, the effort to recover propulsion advanced one system at a time. Steam returned first. Pumps began clearing water that threatened the ship's stability. Limited electrical service brought light and communication back to selected areas. Engineers inspected machinery before committing it to sustained operation. The bombs had devastated everything above the armored hangar section. Below it, essential propulsion equipment had escaped direct destruction. This was the mechanism hidden beneath the spectacle. Franklin survived because her most visible damage was not her most decisive damage. Her upper decks could appear destroyed while boilers and engines remained recoverable. That protection alone could not start them. Smoke had driven engineering crews out and disabled supporting services. The machinery needed people, ventilation, pumps, steam, and control connections. Restoring any one element without the others achieved little. The crew therefore rebuilt a network rather than repairing one miraculous component. Not long after midnight, Franklin could make roughly 2 knots. That speed was insufficient for an independent escape. It proved that the propulsion train still worked. The result changed the central question. Franklin no longer needed to discover whether she could move. She needed to determine how much speed and control the damaged plant could safely provide. Steering remained the next major obstacle. A powered carrier without directional control could endanger every escort around her. The ship initially resisted attempts to hold a steady course. Damage in her remaining list pulled her away from the desired heading. Communication between the bridge, steering spaces, and engine control remained severely restricted. Teams established a narrow chain using surviving sound-powered telephone lines. Orders could pass from the conning position toward steering aft. Another connection carried instructions toward main engine control. It was primitive compared with Franklin's normal communications system. It was also enough at 9:30 on the morning of March 20th, steering control returned to the pilot house. Franklin could finally combine propulsion with direction. Her speed increased as engineers brought more capacity online. Pittsburgh continued towing while the carrier tested each improvement. The tow remained protection against a sudden failure. By shortly after noon, Franklin could make 15 knots. At 12:33, the towing connection was released. Pittsburgh moved clear. For the first time since the bombing, Franklin was proceeding independently. The apparent wreck was now steering away from Japan under its own power. That achievement answered the titleless immediate question. The armored structure preserved the machinery. Distributed damage control teams preserved the time needed to restart it. Improvised communications connected the surviving systems. Human endurance converted those systems into movement, but independence also removed the physical link to Pittsburgh. Franklin remained scarred, lightly defended, and filled with damaged compartments. Her escorts could protect her perimeter. They could not prevent every aircraft from reaching bombing range. At 2:52 that afternoon, a Japanese dive bomber approached from the direction of the sun. The attacker descended toward Franklin's starboard bow before lookouts could provide adequate warning. Some anti-aircraft weapons were damaged. Others had only local control. The carrier turned what guns remained toward the aircraft. Escort ships joined the fire. The bomber released its weapon during the low-level attack. The bomb missed and exploded in the sea. Franklin had survived another direct test this time. She had maneuvered and fought back. Yet reaching open water was only the beginning. The carrier now faced a voyage across thousands of miles with recurring fires, uncertain equipment, and no usable flight deck. The photographs made Franklin's survival appear more mysterious than it truly was. They showed devastation above the hangar. They could not show the strength still running beneath it. Navy investigators later separated spectacular damage from fatal damage. The distinction explained why Franklin survived while less visibly damaged carriers had sunk. An Essex-class carrier used its hangar deck as the hull's principal strength deck. Structures above that level could be destroyed without breaking the ship's main longitudinal strength. Franklin's flight deck, island, galleries, and elevators suffered enormous damage. The underlying hull girder remained effective. The armored section of the hangar deck provided the critical shield. It consisted of 2 layers of special treatment steel. Together, those layers were approximately 2½ inches thick. The armor extended across most of the machinery region. Explosions ruptured it in 4 major places. 1 opening came from an enemy bomb. 3 others came from heavy tiny TIM rocket warheads detonating against the deck. The holes looked serious, yet fragments reached the 4th deck in only isolated locations. That lower armored level formed the overhead above important machinery spaces. It remained largely intact. The boilers, turbines, and reduction machinery received no direct structural damage. Franklin's propulsion failed because smoke, heat, flooding, and lost services forced engineers away. That type of failure could potentially be reversed. A destroyed turbine could not be restored during an escape. An intact turbine without pumps or operators could. The armor, therefore, purchased something more valuable than immediate protection. It purchased time. This did not make Franklin invulnerable. The unarmored section farther aft was torn open far more extensively. Blast passed through lighter decks and wrecked surrounding compartments. Air intakes and uptakes became channels for smoke, fragments, and water. Damage to those passages helped disable boiler support systems. The protective system had been pierced. It simply had not been pierced deeply enough. Another factor was equally decisive. Neither Japanese bomb struck below the waterline. Franklin received no torpedo hit. Earlier American fleet carriers had survived severe bomb damage before underwater damage finished them. Torpedoes opened large flooding paths and destroyed watertight subdivision. They could also remove propulsion permanently by striking machinery spaces directly. Franklin's underwater hull retained its essential integrity. Most of the water inside her came from the effort to save her. Investigators estimated that approximately 2,150 tons accumulated aboard. Water entered through damaged ventilation trunks. hatches, bomb holes, and elevator spaces. It spread across broad deck areas. That free surface reduced stability as the water shifted with the ship's motion. The initial starboard list was therefore not proof of a massive underwater breach. It was largely a consequence of firefighting water entering asymmetrically. Counterfluting and transferred weight eventually overcame that moment. This produced a remarkable reversal. The weapon most likely to capsize Franklin was not another Japanese bomb. It was the water required to prevent her ammunition from exploding. Damage control teams had to fight both threats simultaneously. They needed enough water to cool steel, fuel, and ordnance. They also had to pump, drain, and redistribute it before stability disappeared. The Carrier-S design provided a margin for that struggle. Even under the report's worst estimated flooding condition, Franklin retained positive stability. The margin had narrowed severely. It had not reached zero. That finding removed the word miracle from the technical explanation. Franklin survived through layered protection, intact underwater boundaries, recoverable machinery, and controlled flooding, but investigators also uncovered a more troubling conclusion. The scale of the disaster had not resulted from the two bombs alone. Franklin had been caught during the most dangerous possible phase of carrier operations. Understanding that timing would explain why two ordinary bombs created 126 explosions. Franklin had survived a massive carrier fire once before. That earlier attack provided a controlled comparison. It showed exactly what failed differently on March 19th. On October 30th, 1944, Franklin operated east of the Philippines. A Japanese suicide aircraft crashed through the flight deck. Its bomb detonated near the gallery level and ignited gasoline from parked aircraft. Flames spread across the flight deck and hangar. Vapor explosions reached compartments as low as the third deck. At that time, investigators considered it the worst fire any American warship had survived. Yet the crew controlled the main blaze in roughly 2.5 hours. Franklin retained pressure in her fire main system. Diesel pumps joined the network within minutes. Hangar sprinklers and water curtains activated quickly. Those systems confined the flames until repair parties could re-enter the space. The October attack killed 56 men and wounded 60. It also forced Franklin back to the United States for extensive repairs. She returned to service on January 26, 1945. Less than 2 months later, the carrier was again operating near Japan. The March attack struck under similar conditions but produced a radically worse result. Aircraft were concentrated aboard during preparations for a launch. 31 waited on the flight deck. 22 more occupied the hangar. Many were fueled and armed. The load included conventional bombs and heavy air-to-surface rockets. 12 tiny TIM rockets were positioned on the flight deck. 5 more were inside the hangar. Their rocket motors and large warheads created a threat unlike ordinary stored ammunition. As fire reached them, some motors ignited. Several rockets launched themselves across the burning ship. Others detonated where they lay. Bombs on aircraft also began exploding. Some fell through damaged decks before detonating below. Small-caliber ammunition continued firing or bursting for hours. The carrier was effectively attacking itself with its own weapons. The first Japanese bomb also disabled the forward elevator and nearby control spaces. The second hit among aircraft farther aft and disabled the after elevator. Fuel vapor contributed another violent explosion. Within moments, fire occupied several separated areas. That speed overwhelmed the systems intended to divide the emergency. The central hangar control station was lost. Sprinklers and water curtains then required local operation. Some local stations could not be reached or manned in time. The fire main system had been divided into 8 sections to limit total failure, but brakes, heat, smoke, and power loss made useful pressure difficult to maintain. The engineering plant was initially operating with all boilers online. Dense smoke entering damaged air passages forced those spaces to be evacuated. This removed electrical power and pumping capacity precisely when both were most needed. The comparison with October revealed the first major conclusion. Franklin's armor had worked during both attacks. What changed was the supporting network above and around it in October. Pumps, sprinklers, curtains, and repair parties confined the fire. In March, the attack disabled those tools before they could control the first spread. The bombs did not need to penetrate the machinery spaces. They only needed to interrupt the systems connecting machinery to damage control. That interruption turned a severe fire into a 10-hour conflagration. It also exposed an operational dilemma shared by every wartime carrier. Aircraft were safest when dispersed and unarmed. A carrier was useful only when those aircraft were concentrated. fueled, armed, and launched rapidly. Franklin was hit during that narrow interval of maximum offensive power and maximum vulnerability. The official investigation would identify design changes and procedural lessons, but its most uncomfortable evidence concerned a hatch, a readiness condition, and a radar screen reported clear minutes before the attack. 3 minutes separated the first external warning from the bomb impacts. That interval contained signals, cloud cover, and incomplete information. It was too short to disperse 53 armed aircraft. At 6:17, the task group reduced its immediate defensive posture. The radar screen had been reported clear of hostile contacts. Franklin did not become defenseless. Most anti-aircraft weapons and fire control stations remained prepared to engage, but the crew had spent the night responding to repeated alarms. Men needed food and relief before another day of flight operations. 1/6 of the crew was permitted to eat at a time. The ship adopted a modified high-readiness closure condition. Most openings intended to limit fire and smoke remained secured. One designated hatch between the hangar and second deck remained open. That arrangement balanced survival protection against the movement of hundreds of sailors. It also illustrated the compromises required aboard an operating carrier. A fully sealed ship restricted movement and slowed essential work. An accessible ship created additional paths for smoke, heat, and water. At 6:49, Franklin turned into the wind. Her speed increased to 24 knots for the launch. Aircraft began leaving at 6:57:45 were airborne by the time of the attack. The remaining 53 formed the combustible concentration left behind. At 7:05, Hancock transmitted a warning. Its lookouts had sighted an enemy aircraft approaching Franklin from ahead. One report described the contact as a twin-engine aircraft. The attacker that appeared moments later was identified as a Japanese single-engine bomber. That mismatch did not help the defenders understand the immediate threat. At 7:06, warnings reached lookouts and weapon control positions. The surviving records described the radar picture differently. The wartime damage report stated that the bomber arrived without radar warning. A later naval history described contacts obscured by clutter from friendly aircraft and other carrier operations. Both accounts point toward the same operational problem. No stable track gave Franklin enough time to organize an interception. Low clouds covered the final approach. The cloud base stood between roughly 1,500 and 2,000 feet. Horizontal visibility beneath it was otherwise good. At 7:08, the bomber emerged directly ahead. It was already about 1,000 yards from the carrier. The aircraft descended into a low, masthead-level bombing run. It appeared so suddenly that observers on the bridge did not see it in time. One forward twin 5-inch mount and an island 40mm mount opened fire. Their engagement failed to stop the release. The bomber crossed Franklin and escaped the immediate burst of defensive fire. Its two weapons had required seconds to transform the ship. This sequence corrected a tempting but inaccurate explanation. Franklin was not saved after every safeguard worked properly. She survived after several safeguards failed together. Warning arrived late. The aircraft concentration could not be cleared. The central hangar controls were disabled. Fire main pressure deteriorated. Smoke expelled engineering crews. Normal communication collapsed. The open hatch was one vulnerability among many, not a single cause. Closing it could not have removed fueled aircraft or prevented the bomb hits. The disaster came from accumulated conditions. The recovery worked through accumulated solutions. That contrast shaped the Navy's investigation. Its recommendations addressed protected control stations, local sprinkler operation, repair party strength, drainage, escape routes, and damage control training. One finding was especially severe. The gallery deck above the armored hangar had exposed personnel to blast and fire while offering too few exits. Investigators called it a death trap. Franklin had escaped. The design lessons extracted from her wreckage were meant to ensure that later crews would not need the same combination of endurance and luck. Franklin could move, but she could no longer operate as an aircraft carrier. Her flight deck was unusable. The voyage to safety became a different kind of mission. On March 21st, the danger from Japanese aircraft continued. A twin-engine bomber approached the carrier at low altitude. Friendly combat air patrol intercepted it roughly 8 miles away. Minutes later, fighters destroyed another unidentified contact before it could close. Those interceptions mattered because Franklin's own air group could not defend her. The aircraft launched before the bombing had to land on other carriers. Many of Franklin's regular anti-aircraft crews were no longer at their stations. Volunteer teams operated restored weapons under local control. The carrier needed better warning than lookouts alone could provide. Her forward surface search radar antenna had fallen with the damaged foremast. Technicians recovered the antenna from the wreckage. They mounted it on a platform beside the smokestack. Improvised cables connected it to a surviving receiver in flag plot. Another connection carried the picture to the navigating bridge. The resulting radar arrangement looked temporary because it was. Reports described it as reliable and accurate. That jury-rigged system became Franklin's new set of eyes. Other teams installed temporary electrical cables across damaged sections. They restored selected lights, telephones, and gun circuits. Each repair reduced one dependency on the escorting ships. Speed gradually increased toward 20 knots. Franklin was no longer merely escaping. She was rebuilding limited operational control while already at sea. The work above the armored deck remained slower. Debris blocked movement through the hangar. Smoldering fires persisted inside spaces damaged beyond immediate access. The final recurring fires were not extinguished until March 22nd. Only then could teams safely reach more of the wrecked interior. Franklin arrived at Ulithi on March 24th. The anchorage offered repair ships, protected water, and medical support. It also allowed the crew to assess damage without another air attack interrupting the work. Temporary repairs prepared the carrier for an ocean crossing. No forward base could restore her flight operations quickly. The decision was made to send Franklin back to the United States. On March 27th, she departed Ulithi under her own power. She reached Pearl Harbor on April 3rd. The next stage began on April 9th. Franklin crossed the Central Pacific and arrived near the Panama Canal. On April 17th, she departed the Caribbean side 2 days later for the Atlantic coast. The route demonstrated the scale of the recovery. A ship that could not move on March 19th crossed 2 oceans within weeks. The casualty record explains why that achievement cannot be told as a simple mechanical triumph. Wartime and later sources provide different totals. A commonly cited early figure lists 724 killed or missing. That count also records 265 wounded. More recent naval research gives approximately 807 dead and 487 wounded. The difference reflects changing categories and incomplete early accounting. Air Group personnel, Marines, passengers, and those dying later from injuries were not always counted consistently. The exact total remains sensitive to the method used. The scale does not. Franklin suffered the heaviest loss endured by any surviving American warship, except for comparisons involving the earlier destruction at Pearl Harbor. The carrier reached New York at the end of April. Observers saw a vessel with an open, twisted flight deck and a scorched island. Below that ruin, the same propulsion plant that carried her from Japan was still functioning. The ship had answered whether it could return. Its arrival opened a harder question about what survival meant for the people aboard. Some had remained on Franklin. Others had been ordered, carried, or forced off during the fire. The distinction would soon produce a bitter dispute inside one of the Navy's most celebrated survival stories. Franklin's crew did not agree on who had saved the carrier. The machinery had survived a common disaster. The people returned to a divided memory of it. Captain Leslie Garris remained aboard throughout the emergency. He refused to give up the ship while men were still trapped below. He directed the response from an exposed and damaged command position. The Navy later awarded him the Navy Cross. Other senior officers also received decorations for their leadership. Navigator Stephen Jerica was repeatedly credited with stabilizing decisions during the initial confusion. Chaplain O'Callaghan and Lieutenant Gary received the Medal of Honor. Franklin's company ultimately became one of the most decorated American crews of the war. The awards recognized many forms of survival work. Some men fought fires, some restored machinery. Others handled ammunition, treated casualties, operated guns, or guided trapped sailors. The rescue ships deserved recognition as well. Santa Fe remained alongside while explosions threatened both vessels. Pittsburgh accepted the danger and mechanical strain of towing the carrier. Destroyers recovered people from the water and protected the damaged formation. This collective effort did not fit easily into a story about one exclusive group. During the return voyage, Garris identified 704 people as those who had remained with Franklin. Membership cards created what became known as the Big Ben 704 Club. The number turned endurance into a visible distinction. It also implied that anyone outside the group had made a lesser choice. The reality on March 19th was far less orderly. Explosions threw people overboard. Flames cut off sections of the flight deck. Smoke blocked internal routes. Some sailors entered the water because remaining aboard appeared impossible. Others transferred to assisting ships under orders. Injured men could not simply choose to stay. Aircraft crews already aloft landed elsewhere because Franklin's deck had disappeared beneath fire and wreckage. Confusion also affected whether an abandoned ship order had been heard or merely believed. Against that background, Gerres considered disciplinary action against crewmen who had gone over the side. The contemplated accusation was desertion. The proposal generated controversy because it treated chaotic separation as deliberate abandonment. The Navy ultimately dropped the charges. That decision did not erase the damage among survivors. Men who had escaped the same burning ship now faced different judgments about their conduct. The disagreement complicated public praise surrounding Franklin's return. It also reveals a larger truth about impossible survival stories. Survival is easier to simplify after danger has passed. A list can divide those who stayed from those who left. It cannot reconstruct every blocked passage, blast wave, order, injury, or second-long decision. The carrier survived through both remaining aboard and receiving outside assistance. Removing men reduced the burden on medical teams and damage control supplies. Keeping a core crew aboard preserved the possibility of restoring propulsion. Neither fact cancels the other. The controversy also affected how later historians evaluated Gerres. Some criticized his readiness decisions before the attack and his treatment of separated crewmen afterward. Others emphasized his refusal to scuttle Franklin and his sustained command during the emergency. Both judgments draw from documented actions. Neither requires turning him into the sole cause of the disaster or the sole reason for survival. Franklin's escape was too distributed for either claim. No captain could personally raise steam, clear flooding, restore radar, cool ammunition, and rescue trapped sailors. No individual action could replace the armored deck or intact underwater hull. The ship returned because design margins and hundreds of local decisions aligned before time expired. The Navy's final damage report preserved that complexity more clearly than the heroic publicity. It recorded failures, protection, improvisation, and luck in the same technical language. Its last lessons would outlive Franklin's damaged flight deck and shape how the survival should ultimately be understood. The final investigation did not describe Franklin as indestructible. It described a ship that retained narrow margins after catastrophic failure. Those margins explain every stage of the return. The armored hangar deck limited downward blast and fragmentation. The lower armored deck protected the machinery spaces beneath it. The underwater hull avoided the kind of rupture a torpedo would have caused. Boilers, turbines, and reduction gears survived without direct structural damage. Positive stability remained despite thousands of tons of accumulated water. Those were the physical conditions. They made survival possible. They did not make it inevitable. Franklin's firefighting network failed early. Central sprinkler control became unusable. Smoke entered engineering spaces through damaged ventilation paths. Electrical power, pumps, steering, and internal communication disappeared. 53 fueled or armed aircraft remained aboard when the bombs struck. Their weapons turned 2 impacts into a prolonged internal bombardment. The aircraft carrier was saved only after crews rebuilt essential functions separately. Gerres' escape route preserved hundreds of people trapped below. Fire parties prevented heat from reaching deeper ammunition spaces. Medical teams operated after their normal facilities were lost. Stability teams balanced firefighting against the danger created by its water. Engineers raised steam in the surviving plant. Telephone crews established a minimal path between command, steering, and engine control. Radar technicians assembled a working warning system from damaged equipment. Volunteer gunners defended the ship when trained crews were missing. Santa Fe, Pittsburgh, and the screening ships supplied the assistance Franklin could not provide herself. The mechanism of survival was therefore not one backup system. It was the interaction of many incomplete backups. Armor replaced lost distance from the explosions. Manual control replaced centralized control. Sound-powered telephones replaced the normal communication network. A salvaged antenna replaced the destroyed radar installation. Escort fighters replaced Franklin's absent air group. Human memory of the ship's layout replaced signs, lights, and accessible passageways. Each substitute was inferior to the original system. Together, they remained adequate long enough. That is what carried Franklin away from Japan. The carrier's arrival in New York did not return her to combat. Repairs continued after Japan surrendered. Franklin was restored, but the war ended before she could rejoin the fleet. She entered the inactive fleet in June of 1946. She was formally decommissioned the following year. Despite later changes in classification, she never again served operationally. The Navy removed her from the register in 1964. She was sold for scrapping 2 years later. Her most enduring service came through the evidence left behind. The damage report recommended better protection for hangar control systems. It emphasized local operation of sprinklers and water curtains. It examined repair party strength, drainage, ventilation, escape routes, and communication redundancy. It also warned that gallery spaces above the armored deck could become lethal traps. These were not abstract engineering observations. Each recommendation traced back to a system that had failed while people depended upon it. Franklin's return should not be reduced to a miracle. That word hides the mechanisms and choices visible in the record. The carrier survived because explosions devastated her offensive spaces without destroying her structural core. She survived because flooding remained controllable. She survived because machinery could be restarted. Most of all, she survived because people continued connecting damaged systems after the complete system no longer existed. For 10 hours, Franklin burned near the Japanese coast. By the next day, she was making 15 knots. The ship that appeared finished did not return through one impossible act. She returned because hundreds of smaller acts kept her alive until the machinery could carry them home.